On today's episode, we'll be taking a deep dive into one crucial question. Is there demand for Starship? A high launch cadence is essential for Starship to be fully realized. And this is more than just an engineering challenge. Even if SpaceX can achieve a rapid launch cadence, there needs to be something for Starship to take to space on each of those flights. So let's see what the future may hold for Starship. So, Starship, a 100-ton rapidly reusable launch vehicle. It sort of begs the question, are there hundreds of tons of stuff needing to go to space every few days? The short answer is no, not right now, and as far as we know, there's not any customers planning to launch a bunch of 100-ton objects soon, so what will Starship actually have to launch? There's a common misconception that rockets need to fly at or near 100% capacity. This just isn't the case. Even today's expendable rockets rarely fly at their max capacities. The vast majority of payloads launching today are less than 15 tons. So how could Starship compete with smaller vehicles that are far more optimized for the existing market of payloads? After all, these smaller vehicles cost way less to develop, they're cheaper to build, they use less fuel, they require less infrastructure to launch, and so on. You may have heard it said that you wouldn't charter a 747 to fly something across state lines, you would take a small Cessna. This isn't actually true. If it was the cheaper option of the two, you would take the 747 almost every time, no matter how overkill its performance may be. The same will be true for Starship. Just because it has a massive capability doesn't mean it must be relegated to flying only massive payloads. As discussed in the series intro, Starship will likely be much cheaper than Falcon 9 to fly, meaning that every payload Falcon 9 has flown, no matter how small, Starship could have flown for less. Full and rapid reusability, if achieved, could make Starship cheaper to launch than most rockets in existence, even small launchers. And this is before we even mention ride-sharing payloads to save costs. So, up front, I just wanted to dispel the notion that there isn't demand for Starship because there aren't a bunch of monolithic 100-ton payloads needing to be launched. In fact, Starship seems well positioned for competing in almost every sector of today's launch market. Let's take a quick look at how well adapted Starship is to the current launch market. Typical medium and large satellites are obviously in its wheelhouse, both to low Earth orbit and geostationary orbit. As stated in the intro, Starship can launch more mass to GTO than any existing or planned competitor, and it has enough room to ride-share several big satellites to GTO at once. Starship also looks well positioned to launch the ever-growing list of constellations. High launch cadence mixed with large volume and mass capabilities means Starship can deploy constellations rapidly, and it's even conceivable that Starship could deploy an entire smallsat constellation in just one launch. The moon is getting more and more attention as NASA's Artemis program heats up, and honestly, it's hard to imagine a vehicle better poised to rake in cislunar contracts than Starship. Starship is likely to eat up a big portion of these contracts the later half of this decade, the same way Falcon Heavy is currently raking in lunar missions left and right. And this would of course be on top of all the missions for the HLS Starship and other potential future Starship roles in Artemis, such as bases and so on. Now, hot off the heels of Inspiration 4, we have to talk about human spaceflight and tourism. SpaceX has already said there are many more private missions being planned for Dragon right now. If Starship can be made to safely and routinely launch and land, then it will almost certainly book more of these sorts of missions. On short flights, Starship can easily fit hundreds of people. More people at a time at a significantly lower launch price will make tickets cost a fraction of what they did on Dragon. Now, SpaceX has already booked one lunar tourist flight on Starship, Dear Moon, so I would also expect more of this sort of mission as time passes as well. Space stations are also going to be a big ticket item over this next decade. The ISS will be aging out of operation soon, and NASA has a plan to replace it with Commercial LEO Destinations, or CLDs. I don't have time to go into all of the details on this right now, but trust me, a video is coming. What that means for Starship is opportunity. Opportunity to launch these space stations, resupply these space stations, ferry people to and from these stations, and perhaps even be the station. It's known that SpaceX has bid to be a CDL, and they likely bid a variant of Starship formatted to be a space station. That's a long way of saying that if Starship works, it's well positioned to compete for contracts in basically all existing niches of the orbital launch market. Suborbital applications is another arena of potential demand, but we'll have to save that topic for another video. So, the same vehicle is going to carry small sats, geobirds, space stations, people, and take stuff to the moon? This spawns a lot of questions. How can the largest rocket in history compete economically with dedicated small and medium lift rockets? Will the customer launching a huge space station pay the same price as the 500 kilogram smallsat customer? With expendable rockets, we're used to launch prices falling within a fairly tight range. But like with most things, I expect Starship will have a very different sort of pricing. First, let's break down how a rocket arrives at a launch price. This subject is obviously pretty complex, so this example is simplified, but it should give the general principles. Let's say this green bar is the average price a customer pays to ride to space on this expendable rocket. We can break this price down into two parts: the internal cost, the price it costs the company to launch the rocket, and the profit, which is the difference between the internal cost and the launch price. This is the cash the company gets to take home. We can break down the internal cost further into three main categories: how much it costs to fly the rocket, that's your insurance, pad repairs, fuel costs, and so on. And then you have your build costs, the material, labor, and tools involved in constructing the rocket that you can only use once. And finally, your annual fixed costs divided by the number of missions you expect to fly that year. Let's say that it's spread over 5 launches, since that's the average annual launch of Atlas V for the past 5 years. Now, let's look at a fully reusable rocket like Starship. We still have our profit and the internal cost, but the breakdown of our internal costs changes dramatically. Obviously, we still have the operational cost to launch the rocket, but now we don't have to build a new rocket every single time we launch a mission. So we can divide the build cost by how many times we expect our rocket to be used. Now, reusing the rocket isn't free, and even though Starship is being designed to have as little maintenance between flights as possible, there will still be some cost associated with inspection and refurbishment. So, we can add a new category to the breakdown of internal costs, refurbishment, but it's only a small amount. As for our annual fixed cost, well, we can fly the rocket a lot more since we don't have to build a new one for every mission. So, now we can divide our annual operating costs by a lot more than 5. The Falcon 9 flew 25 times last year, and only its first stage is reusable. Basically, even if operations remains the same, all other costs can become so small that your internal cost is way lower than it is with an expendable rocket. Now, lower costs due to reuse is no surprise, at least it shouldn't be. But what you may notice is that the price range has grown dramatically. I believe we will see Starship launches with some wildly different pricing. There may be Starship flights where the customer is only paying a few $1,000,000. Let's say it's a small sat contract and SpaceX is bidding against small launchers like Electron and Astra. So it must bid competitively and eat deep into that profit margin. But at the same time, there may also be customers paying well over $50 million to fly on Starship because their payload requires a medium lift rocket, in which case SpaceX will be bidding against rockets like Vulcan and New Glenn, which are likely to be priced north of $100 million, allowing SpaceX to charge way more and recoup some of their investment into Starship. For now, I expect them to price each launch near the maximum they can get for it, the same way they have done with Falcon 9. Moving on from our current market, it's important to ask, can lowering launch prices grow the market and lead to more demand for Starship and others? This is asking the question, is demand for launch elastic or inelastic? In my opinion, this question has largely been settled. Since the reduction in launch cost brought forth by rockets such as Falcon 9, we have seen the birth of constellations and mega constellations by SpaceX, Amazon, OneWeb, Telesat, and other private companies and governments. Analysts expect the space economy to triple in the next 10 to 20 years, and investment has grown by leaps and bounds in the industry since 2012. This investment has been led by venture capital and huge financial players, Amazon, Microsoft, Google, Apple, alongside the two richest people on Earth, Bezos and Musk. All of this attention and investment in the space sector means some amount of growth is inevitable, and we already see some of it, but it's likely only the beginning. So, I think it's safe to say that the market is elastic. Just how elastic remains to be seen. It's also worth noting that there's a demand response curve to take into account. A lot of space activity and business plans take years to develop, so growth in demand could potentially lag quite a few years behind a drop in price. The important question is, what business cases will financially close due to the reductions in costs brought on by Starship? I don't have the answer to this, and no one really does, but it may be a fun future episode to speculate on. Now, launch costs are only one of many cost factors for a business that's looking to operate a product or service in space. A quick list of costs off the top of my head include business operations, development, materials, testing, payload and sensors, and launch. So which of these cost factors can Starship potentially bring down? Business operating costs? Not really. As for development costs, Starship may bring this down a little bit due to its immense scale. Size and weight of your satellite doesn't really matter in most cases, and this could radically reduce complexity in spacecraft design and engineering. When a kilogram isn't quite as precious, thermal and radiation management can be counteracted more easily. Still, weight will matter some for on-orbit station keeping. Materials, the same thing really. Expensive exotic materials meant to counteract the harsh space environment while saving mass can be swapped for strong, cheap, and more common materials. So some savings here. But many spacecraft parts are just expensive, period. Star trackers, solar panels, engines, and so on. Starship won't change that. Testing also won't change much. They still have to do this even if your spacecraft is resilient and may pass the tests easier. Starship also won't decrease the cost of payload and sensors. The payload I'm referring to here is the payload that goes on the spacecraft, which together become the payload of Starship. This is usually some sort of sensor, and Starship won't change this cost factor. And finally, we have launch. Obviously, Starship would greatly affect the cost of this. Now, Rocket Lab and SpaceX are both separately looking at ways to address all of these cost factors I just mentioned, so subscribe for a discussion of that in a future episode. The difference here is the total cost reduction to a space business brought by Starship. No one knows what this number will be, and it will be slightly different for every business. So when we return to our question, what business cases would financially close due to the change in cost brought by Starship? The answer is whatever business ideas now seem possible at this cost, but weren't possible before at this cost. Based on the evidence of elasticity from Falcon-era cost reductions, I would predict that there's going to be some growth in the market due to the cost reductions of Starship and Starship's potential competitors. How much the market grows and how long it lags behind the cost drops, I don't know. Now I want to make a realistic manifest of future Starship flights. I think this will help us better visualize the amount of flights and the cadence of them. Now, of course, this manifest presupposes that Starship works, meaning a fully reusable vehicle and a reasonable turnaround time of a week or so between flights is achieved. Nothing too crazy. So let's start with next year, 2022. I think 4 test flights is a reasonable guess. They'll be learning how to get to orbit and how to survive re-entry, and it's looking like they'll get approval for about 5 orbital flights per year from Boca Chica for early testing phase, so I would expect something close to that. I think it's very likely we will see a successful orbit before the end of 2022. For 2023, I think we see at least 5 more dedicated test flights, proving out orbital capability and practicing stuff like re-entry. As soon as Starship is making orbit reliably, they can begin offsetting the cost of these flights by flying payloads to orbit while they continue to test recovery of both stages, just like they did with their Falcon 9 program. The first of these payloads will likely be Starlink missions with some potential rideshare customers. We may see the first dedicated customer mission around the end of this year, so I just put 4 Starlink missions and 1 customer flight to bring us to an even 10 launches on the year, so launching slightly less than once a month. Next up is 2024. From here on out, I'm not putting any more dedicated test flights. Now this doesn't mean development is over, it just means all remaining upgrades and tests are done while flying missions. Starlink is launching at about once a month, and SpaceX is starting to sign more launch contracts for Starship, so I give them 10 customer flights this year. Finally, there's a Mars window late this year in Q4. I absolutely expect SpaceX to send some Starships during this opportunity. It's really just a question of how many. And in the theme of being conservative, I went with the bare minimum. 1 Starship refueled as little as possible, just to test the flight and landing with an expected failure. So that's 4 launches. On the screen now, I'm gonna start tracking potential Mars and Moon landings just so we can keep up with them. So in 2024, we had a total of 26 launches, which means a launch every 2 weeks. So on to 2025. By now, New Glenn, Neutron, and Terran R are likely all on the market, and SpaceX has at least 3 Starship launch sites. Starlink is now launching twice a month, so 24 launches this year, and we'll give them the same 10 customer flights that they had last year. Remember, SpaceX is still launching on Falcon 9 and Heavy during this time as they transition. Now, you may have noticed that Artemis HLS missions should have had a test landing in 2023 and landed humans on the moon in 2024. I think this timeline is pretty much impossible at this point, so I just moved it back 2 years. So I'm putting the first uncrewed HLS landing this year in 2025, which will require about 10 flights, bringing the annual total to 44 flights, or a launch every 8 days. Our cumulative total is now 84 launches, and they've been working on life support for HLS, so I'm thinking serious work is beginning on preparing Starship for crewed launches and landings. Now 2026. Starlink pace continues to increase, and I'm putting 36 of them this year. Again, let's add a conservative 10 customer launches. For Artemis, we have a big milestone, the first crewed HLS landing and the return of humans to the moon. That'll take about 10 launches. And finally, we have another Mars window late in the year. I'm gonna say SpaceX sends 3 ships to Mars, this time with some payload. Probably some ISRU test equipment, and NASA will likely be involved at this point, sourcing experiments and equipment to go on the ships. This will take about 24 launches, bringing our annual total to a whopping 80, more than once per week. But don't let this big number fool you. This really isn't that ambitious for SpaceX. By 2026, they could easily have 3 or 4 pads operating, 2 super heavy boosters and 3 ships or so at each pad. If we distribute these 80 launches evenly, each pad is only seeing about 20 launches per year, meaning they only have a launch every 18 days. SpaceX is already turning around Falcon 9 pads much faster than that, and the ships themselves would enjoy even longer turnaround times as they swap in and out for each mission. On to 2027. Starship has been flying for years now, and operations are getting smoother and smoother. Starlink is launching about once a week, accounting for 52 launches, and SpaceX is beginning to phase out Falcon rockets, so the dedicated customer flights jump to 25. Starship has flown well over 150 times by now, and has likely landed over 100 times successfully. So crewed Starship flights are probably happening, which are included in these 25 customer flights I just mentioned. But one of those customers fall into the Moon category, and that, of course, is Dear Moon. It's finally time to send these 12 passengers on their lunar flyby, requiring just 3 launches. We have another Artemis moon landing, bringing our moon launches on the year to 13 and netting SpaceX their 3rd lunar landing, ending the year with about 90 total launches. Next up is 2028. Again, we're getting a Starlink launch once per week, and 35 customer launches as the transition to Starship is nearly complete. 10 more flights for an Artemis landing brings our annual total to 97, and the total number of Starship launches to a staggering 351. So before we move on to 2029, let's take a step back and look at just how much the rocket world has changed. It's the year 2028. Starship, New Glenn Jarvis, Vulcan, Terran R, and Neutron have all been flying for years. Starship has launched and landed with people several times. It's landed humans on the moon a few times, and even flown private passengers around the moon and back to Earth. And it's probably even landed on Mars. It's hitting an annual cadence of nearly 100 launches. Meanwhile, SLS has flown at most 7 times. At what point does NASA start launching astronauts to the moon and returning them to Earth, all on Starship? And this could be done in addition to SLS or as a replacement, that doesn't really matter. But this conversation has got to be reaching a boiling point at this stage. So in 2029, we start getting a few changes. I'm dropping Starlink way down to just 1 maintenance flight because the constellation is close to full deployment and we've got some more important things to do this year. 35 more customer flights this year. Basically, the only flights on Falcon are Dragon missions to the ISS if that's not yet decommissioned. Now, Starship is doing full Artemis missions. I'm gonna say NASA is using other landing systems alongside Starship, so SpaceX is only asked to do a modest 2 landings each year, so 20 Artemis flights. And we have a Mars window this year in Q1. At this point, SpaceX has landed on Mars and had years to prepare for this window, making some cash off of Starlink in the meantime. NASA will definitely be involved at this stage. This is going to be a big push from SpaceX here to prepare Mars for the first wave of colonists. So I put 8 ships fully decked out with 100 tons between NASA, SpaceX, and their partners, totaling 64 launches. The goal here is to build some infrastructure and, most importantly, test a return flight of Starship from Mars to Earth. I don't think NASA or SpaceX would send humans to Mars without first having demonstrated the ability to get them back to Earth safely. Some of these 64 launches would have happened in late 2028, but it's just easier to lump them all into this year, giving us around 120 flights, or a launch every 3 days. As we move to 2030, SpaceX finishes off Starlink deployment with 69 launches, nice, and the ISS is decommissioned, as is Falcon 9, truly the end of some eras. but Starship and other large rockets will be putting up some different stations probably, and if we're really lucky, bringing the ISS back down to Earth so we can see it here. So let's add the usual 35 customers and 2 Artemis landings to bring us to 124 launches. Finally, we've reached the end of my 10-year manifest with the year 2031. Starlink 2.0 has deployed all 30,000 satellites, so just a flight or 2 replacing dead ones is needed. Again, we'll put 35 customer launches and 2 Artemis landings, and finally we have another early Mars window. Assuming things have gone well so far, we could see the first people going to Mars in this window. So I'm gonna say 12 ships are sent on this important journey, requiring 96 flights, bringing the 2031 total to just over 150 launches. Whew, we're done. I know that took a while, but hopefully taking the time to watch the progression from testing to over 100 flights per year made it all seem a little more achievable. I mean, look at our totals. 747 total launches, 10 attempted moon landings, and 24 attempted Mars landings. If I had just blurted these numbers out without going through it all, you probably would have rightly turned off the video thinking I'm crazy. Now 750 launches is quite a lot, but remember, this manifest is presupposing that Starship basically works as intended. And yes, I do think this manifest is rather conservative. With this list, I'm saying that Starship won't expand the launch market at all, not even a little bit, which I find unlikely. Even 10 years out, I'm only giving it 35 customer payloads per year. Just to show how pessimistic this is, SpaceX has 38 payloads scheduled on Falcon next year alone, and that doesn't even include Starlink. This list also excludes any possibility of point-to-point flights. So yeah, if Starship achieves a very rapid turnaround time, and the market does expand a little bit, the numbers could get even more outrageous. So basically, what I'm saying is, I see Starship working about this well, or even better. Anything much less than this, I would just consider a failure of the Starship project, which is a scenario we'll be analyzing in a future episode. So to answer the question, is there demand for Starship? Yes, there's plenty of demand. The only potential problem I see here is that a big portion of the demand is from SpaceX themselves. Starlink and Mars flights make up close to 60% of all of these flights. But even this isn't a huge concern in my opinion. Starlink isn't just an expense, it's also an investment, and the plan is for that to net profit for SpaceX, so the cost of these launches should be cancelled by Starlink revenue and actually make SpaceX money. So that makes Mars the biggest cost, which is kind of the point. SpaceX and Starship were created for this purpose. This is the reason SpaceX isn't a publicly traded company. SpaceX will likely spend as much money on Mars colonization as they think they can get away with. And Elon, a man with a lot of money, will also be spending a lot on this project. But even some of this cost will likely be shared because NASA wants to get astronauts and all sorts of other stuff to Mars and will pay SpaceX very well to take them there. NASA isn't going to sit on the sidelines while SpaceX sends waves of 100-ton landers to Mars, and SpaceX will benefit greatly from their partnership. As always, let's close out with my final thoughts. I think Falcon Heavy may actually be behind some of the concern for demand we've seen for Starship. We know that for a big reusable rocket like Starship to financially work, it needs to launch a lot. And then we think of Falcon Heavy. It isn't even as big as Starship, and it doesn't get a ton of launches. But there's an important difference. Falcon Heavy was meant to be a more expensive, more capable addition to the Falcon family. Starship was meant to replace the Falcon family, to be cheaper than the Falcon 9 to fly. If Falcon Heavy was cheaper than Falcon 9, you would see it launching all the missions Falcon 9 has. Between the current market, 30,000 Starlink satellites, and having to refuel for every Moon and Mars mission, I think Starship has enough launches on its plate to reach a cadence faster than once per week. Any extra demand that arrives in the market is just a cherry on top. And remember, Starship isn't going to reach a fast cadence overnight. So SpaceX has time to build out demand for Starlink, build out demand for Moon and Mars missions, and for the market to grow. Thanks so much for watching the video and for your patience with me getting it out. That's it for this episode. Please like and subscribe, and I'll see you next time.